Hi guys, welcome. This is Matt with Esomnofo. In this video, I'm going to solve a simple bearing question we have on the board. Recall, bearing can be seen as the angle measured from a clockwise direction from the North Pole. Okay, if you look at the board, we are told that y is 60 kilometers from x on a bearing of 135 degrees. This is a 3-digit bearing. Z is 80 kilometers away from the same x on a bearing of 225 degrees. Find the distance between z from y and the bearing of z from y. For us to do this, we'll first of all represent this information on a diagram. So recall that we have the North Pole. This is the North Pole. Now, they said that y is 60 kilometers from x on a bearing of 135. So since it is from x on the bearing, that means point x is here. Recall it is 135. The first quadrant is 90 degrees. The second quadrant is 180, 90 plus 90. But here we are requested to do 135. So we are going to do 135 degrees minus 90 degrees. So you can say it is 45 degrees. So if you take it from here, here is what? 100 and what? From here to here now is 135 degrees. So here is 135 degrees. Okay, to a point 60 kilometers. To a point y, to a point y. So here is y. So at this point, so here is y. That means here is 45 degrees, and also here is 45 degrees, because 45 plus 45 is 90 degrees. So here is the North Pole of the what? Y. So we have represented the first statement. Then the second statement is that z is 80 kilometers away from x on a bearing of 225 degrees. So on the same x, we are going to get 225 degrees on a bearing. From here to here is 180 degrees. Then we are looking for 225 degrees. So we are going to do 225 degrees minus 180 degrees. And that will also be 45 degrees. So here, from here to here is what? Somewhere here is what? 45 degrees. You can now see that it is what? It is how many kilometers? 80 kilometers. So here is our z. Okay, here is our z. Let's just complete this line to make it a proper triangle. Okay, here is the z. We have drawn a triangle now. So angle here is 45, angle here is 45. That means the whole angle here is what? 90 degrees. Let me use the proper way of doing it. 90 degrees. Okay, then since here is 90 and here is 60, the first question they asked us is just that we are going to find the distance from z from r. So this is our z, this is our r. So we want here, since this side angle is 90 degrees, the angle that is facing the right angle is always the hypotenuse, because this is now a right angle triangle formed. So we use Pythagoras rule to solve right angle triangle problems. So I use Pythagoras, which says that hypotenuse squared is equal to opposite squared plus adjacent squared. The hypotenuse is usually the longest side. So the hypotenuse is unknown. Here can be x, the length x. We use it as x squared is equal to the square of the two opposite sides now, 80, this 80 kilometers squared plus 60 kilometers squared. Okay, so 80 kilometers squared will be 6,400. 60 kilometers squared will be 3,600. Okay, we have our x squared here. So if you add this two, you are getting 10,000. That means x squared is equal to 10,000. Okay? To get the x, you take the square root of both sides. If you take the square root of both sides, you can see that this length x is equal to 100 kilometers. So the length here is what? 100 kilometers. Then the next thing they asked us is that we are going to find the bearing of z from y. So our concentration will be the angle it moved to get to what? Z. Okay? So for us to do that, since this is a right angle triangle, you can choose any trigonometrical ratios you want. I choose the sine because the three sides are given. So if I use sine theta, it is opposite over hypotenuse. So here is the angle we really want to find first, not just the bearing, just the angle. Let's represent it as theta. Okay, if we find this, that means sine theta is equal to the opposite to this angle is this one, 80 kilometer over the hypotenuse is the side we found, which is 100 kilometers. You have 100. That means sine theta is equal to 0.8. Okay, to get theta, we just do sine inverse of 0.8. Okay, because that's theta. That means theta is equal to 53 degrees. So the angle here is 53 degrees. Okay? Since the angle here is 53 degrees, you can now see that the bearing from this will be equal to, recall the angle at a point is 360. It will be equal to 360 degrees minus, there is a movement from here to here, 360 minus, since we are needing the angle from movement to up here, we've gotten here to be 53 degrees here, and we know that this angle is alternating here, which means here is 45 degrees. When we take away these two angles from 360, which is the angle at a point, we are going to find the bearing.